Hello, and welcome to Backer Breaks It Down. In this episode, we are going to look at angles and their measures. Okay, now you would have studied angles back in geometry, and we measured angles in terms of degrees. And in geometry, our angles were never smaller than 0 degrees or bigger than 180 degrees. But this is trig, and while things are a little different in trig, okay. So first off, in trig, an angle is formed by rotating a ray about its vertex from one position called the initial side of the angle to another called the terminal side. So notice the initial side is on the positive x-axis. Okay. Also notice that red arrow there. Now that red arrow is important because it's showing us direction. Because in trig, angles can be positive or negative. Okay. Now, if that red directional arrow is moving in a counterclockwise rotation, then the measure of our angle is positive. Okay. And if it's going clockwise, then the angle is going to be negative. So below here, I have an example of a positive angle versus a negative angle. Okay, so this first one, they're saying the angle alpha is in standard position and alpha is positive. So standard position means the initial side is along the positive x-axis, and then you've got your terminal side. Notice the directional arrow. Okay, that is moving in a counterclockwise direction, making this angle positive. Okay, whereas on the right-hand side, theta is in standard position with the initial side on the positive x-axis. However, there's your terminal side, and look at that directional arrow. It's going clockwise, making this angle negative. So that directional arrow is important because it shows us whether our angle has a positive measure or a negative measure. It's also going to show us rotations because in trig, our angles can be bigger than 360 degrees. They can also be smaller than 0 degrees. Okay. Right. So before I get into multiple rotations, let's check out example number 1 here. Now it says, find the degree measure of the angle for each rotation and then sketch the angle. So one thing we have to pay attention here is to the direction. Is it counterclockwise or is it clockwise? So in problem A, it says 5/4 rotation counterclockwise. Counterclockwise means it's positive, and one positive full rotation would be 360 degrees. I'm going 5/4 rotation. So I would go 5/4 times 360 degrees. And I can do this on a calculator. I get 450 degrees. So since it's positive, well, no matter what, I'm starting always on the positive x-axis. 450 degrees. So I'm going to go counterclockwise. And if I go once, that's 360. Okay. But I need to go 450. So I need to go 1/4 of a rotation more, like so. Okay. Do you see my directional arrow? My directional arrow is showing that I went more than one rotation. Okay. It's also showing that I went in the counterclockwise rotation. And that is important when we're working with angles in trigonometry. So on B, I'm working with 2/5 rotation. This time it's clockwise. Clockwise is negative, so one full rotation would be negative 360. So I go 2/5 times negative 360, and I do my math, and I get negative 144 degrees. So when I go to graph this, I have my initial side on the positive x-axis. I want to make sure this time I'm going in a clockwise direction. So I'm going to go like so. So that's like approximately negative 140 degrees. Okay. And then I can draw my terminal side. So this arrow is important. It's showing direction. It's also showing like if you go more than one like rotation, it's showing that. So speaking of these multiple rotations, so coterminal angles are angles in standard position whose terminal sides coincide. So like if you look at this diagram over here, they're showing us like the whole big angle is 495 degrees. Okay. Well, that 495-degree angle is coterminal with an angle that measures 135 degrees. So from here to here, that's just 135 degrees. So how can we find coterminal angles? Well, we can add 360 for every counterclockwise rotation and subtract 360 for every clockwise rotation. Okay. Below, I have another example, well, two more examples of coterminal angles. So they're saying the 60-degree and the 420-degree angles are coterminal simply because if I go 60 and then I go all the way around in the positive direction, 60 plus 360 is how they're getting 420. Likewise, on the right-hand side, the 240 and 120, if I go 240 minus 360, because let's say I want to go in the negative direction, that's how we're getting the negative 120. So in this one, they are subtracting 360 for every clockwise rotation. So realize, like, when it comes to coterminal angles, like each and every one of us could come up with a different coterminal angle simply by like going around multiple times. Okay. True. So name 3 angles, 2 positive and 1 negative, that are coterminal with the given angle. So my given angle is 40. So if I simply add 360 to it, I'm going to get an angle coterminal with that, and that angle would be 400 degrees. And then I could add 360 to that once more, and I'll get 760 degrees. Okay, so 400, 760 are coterminal with that 40-degree angle. Likewise, if I were to go 40 minus 360, I would get that negative coterminal angle they speak of, so negative 320 degrees. So you simply have to add or subtract 360 to the given angle to find the coterminal angles. Okay, so for negative 34, if I add 360 to that, one of my coterminal angles would be 326 degrees. If I add, yikes, 360 to that, I get another coterminal angle of 686 degrees. And then to find like the negative coterminal angle, I can subtract 360, get negative 394. So let's actually take a look at these angles here. And it wants to know, what is the measure of the angle shown? So the couple of things we want to pay attention to is direction, because remember, counterclockwise is positive and clockwise is negative. And we also want to pay attention to rotation. Okay, so when I look at A, I notice, and if you look at that directional arrow, it is going clockwise. So what that means is I'm working with a negative angle measure. Also notice it goes one full, sorry, it is counterclockwise. You're right. Thanks for catching that for me. It goes one full counterclockwise rotation. So it goes a full 360 degrees. And then it goes 35 degrees more. So if I add 35 degrees to that one full positive rotation, I get an angle measure of 395 degrees. All right, so we're paying attention to direction and rotation. So if we look at B, this one is clockwise. Okay, and so we go one full clockwise rotation, so that's negative 360 right there. And then it goes a bit more, because like this part right here, that would be negative 90 degrees more. And then it goes a little bit beyond that, 30 degrees. Okay, so another negative 30 degrees. So if I were to like take all these and add them together, I would get the actual full angle of negative 480 degrees. Okay. So this is how we can measure angles in trigonometry. Yeah, we can still use degrees, but they can be bigger than 180 and smaller than 0, all because of that whole coterminal nature. And that directional arrow is going to show whether it's going in the positive direction or the negative direction. And that's how Backer breaks it down.